Hello and welcome to G.5 Lesson 1. We're going to be talking about relationships in triangles today. Alright, so the first thing that you need to know about triangles is how to find a missing angle. So if we have this triangle and it tells us what two of the angles are, but we don't know what this missing one is, that can be a problem. So the main thing you have to know is that all the angles in a triangle add up to 180 degrees. Now, this is important. It doesn't matter what kind of triangle it is, whatever, but whenever you see any triangle, the angles inside it add up to 180. So we can use that to find our missing piece. I think the best way to do this is to add up the other two. So I added up 32 plus 61 equals 93. And then subtract that answer from 180 to find the missing part. So I did 180 minus 93 and got 87. And that is my missing angle. And if I want to check my work, I can add together 87 plus 32 plus 61, and it should get 180. So another thing we can do in triangles is if we're given the angles, like in this picture, we can put the sides in order from smallest to biggest, or biggest to smallest, whatever they ask for. And here's how we can do that. The longest side in the triangle is always going to be across from the biggest angle. And the shortest side is always going to be across from the smallest angle. So let's see how that works. If we need to put the sides of this triangle in order from shortest to longest, I know that my shortest side is across from the smallest angle. So I'm going to look at these angle measurements and find the smallest one, which is here, 32. And then I'm going to look at the side that's all the way across from that angle. And remember, we name sides with two letters, so I would call this side BC, and that's my shortest one. Then my next smallest one is going to be across from my next smallest angle. So it looks like that is 61. So if I go all the way across the triangle, that side is AC. And then my largest side is across from my biggest angle, which is 87. So I look all the way across the triangle, and that's side AB. So here we go. From shortest to longest, we have BC, AC, AB. Now I want you to notice that if you look at this picture, it looks like we did it wrong because, at least to me, AC looks a whole lot longer than AB. But this is where they're going to try to get you. The picture is not always going to match what the right answer is. So it's really important that when you get a question like this, you actually look at the angle measurements instead of just trusting the picture. The picture is nearly always going to be lying to you. So very similar, if we have the sides, we could put the angles in order from biggest to smallest. And it's going to use the same idea, that the longest side is across from the biggest angle, and the shortest side is across from the smallest angle. So let's say we want to put the angles in order from smallest angle to the biggest angle. Well, first, I'm going to find my smallest side. Looks like that is 27. And my smallest angle is going to be all the way across the triangle from that. And remember, an angle is just one letter. It's in the corner. So that would be angle C. Then my next smallest angle is across from my next smallest side, which is 32. So I go all the way across and get to angle A. Finally, my biggest angle is across from my biggest side here, which is 34. So I'm going all the way across and get angle B. So there we go. From smallest to largest, we have angle C, angle A, then angle B. Another thing that you may be asked is if you're given any three numbers, they might say, do these make a triangle? And what they mean is if we had sides that were those lengths, would they connect to make a triangle? And you might be saying, well, everything makes a triangle. but not necessarily. Like, what if we had a side that was really long, like this one I'm sketching, and then this one was really short? There's no way that we could connect those to make a triangle. So it does actually depend. And here's the rule that we can use to help us figure that out. If three sides make a triangle, the two smaller sides must add up to be more than the biggest side. So here's an example. If we have 3, 4, and 8, I'm going to look at my two smaller sides, so 3 and 4, and I want to add them up. So 3 plus 4 is 7, okay? If this is going to be a triangle, that sum there, that 7, would have to be bigger than this biggest side, 8. And that's not true. 7 is smaller than 8, so this is not a triangle. Here's another example. We have 15, 12, and 13. So I'm going to look for the two smallest ones. They're not always going to be in order, just FYI. So 12 and 13. And I'm going to add those up. And 12 plus 13 is 25. And 25 is a lot bigger than 15, so we are good. That is a triangle. All right, here's one last example. I'm going to find my two smallest sides. So it looks like 2.5 and 3.7. And I'm going to add those up. And 2.5 plus 3.7 is 6.2. Now here's the catch. 6.2, that's the same as our biggest side here. But if this is going to be a triangle, this sum has to be bigger than the biggest side. And it's not. It's the same. It's not bigger. So this is not a triangle. The last little topic here is, how do you find the range of the third side? And what this means, here's an example, is they might give you two sides of a triangle. So they're saying, okay, we have 13 and we have 10. Those are two of our side lengths. And I want you to find the range that the third side length can be in. In other words, what's the smallest possible side that would fit and make a triangle? And what's the biggest possible length that can make a triangle? And to find the smallest possible length, we're going to subtract the two sides that are given. So I did 13 minus 10, and I got 3. So that's our smallest possible one. To find the biggest possible one, I'm going to add the two side lengths that are given. So 13 plus 10 is 23. So there's my range, 3 to 23. I just need to put it all together. And you usually see this written as an inequality, like this. 3 is less than x is less than 23. What this means is that x is in the middle of 3 and 23. It has to be some number in between there. The reason we use less than and not less than or equal to is because if you remember from the last slide, when you add up the two smaller sides, they have to be bigger than the biggest side, not equal to. So that's why you just have these less than signs here. All right, and that is it for relationships in triangles. Make sure to check out the quiz on Schoology. Thanks for watching.